All right, guys, it is Friday, August the 24th, and we are going over, these are going to be the notes for Friday. I know you're in good hands. Sorry I'm not there, but go ahead and take this for your notes. We are talking about inequalities, and inequalities we know are the greater than sign, less than sign, greater than and equal, less than and equal. Okay, so when we're graphing inequalities, we're going to use a closed dot for the when you have a greater than or equal to or a less than or equal to. So anytime you have a equal sign underneath there on the graph, whether it be a number line or whatever, or on a three-dimensional or a axis, it's going to be a closed dot. You're going to use an open dot when it is greater than or less than. Basically what that's saying is the number where that open dot is not included. Not included. The closed dot means that that number is included. Okay, so hopefully that's a review for you. Interval notation is a different way to write inequalities, and we're going to talk about both. This is basically when you use parentheses or brackets. So the parentheses, for an example, if you were to write a interval notation like this, where you were 5 to 8, basically what that means is that it is all the numbers between 5 and 8, but not included. So this would be your open number line. So if this was 5, this would 8. This notation would mean an open dot here, an open dot there, and all of the numbers in between. Okay. The brackets, which look more squared off, like that, if you had 5 to 8, would basically be the same thing. I'm going to make this bigger so you can see it a little bit better. If you had 5 here and 8 here, it would be a closed and all numbers in between, which means that 5 and 8 would be reasonable answers. Okay, so let's go over that. So for an example, we've got x is greater than or equal to 8. So since it's greater than or equal to, we're going to use a closed dot. And we would put it, so for an example, if this was 0, this was 4, 8, 12, 16, we would put a closed dot on 8, and x has to be any number that is bigger than 8. So that's going to be all the numbers over here and on. Okay, here we've got a is less than -1. So we are going to use, since it's not greater than or equal to, we're going to use an open dot. Okay, and that means that if a was -1, -1 is not less than -1. It's equal to it, but it's not less than it. So that would not make that statement true. So for an example, if we had, this was our number line, and we had 0 here and -1 there, say positive 1 here, we would have an open dot here, and A would be all the numbers smaller than -1, which would include -2, -3, and so on. It does not include -1 though. That's why we leave that dot open. This includes 8, which is why we leave that closed. All right. Solving inequalities. Basically, you use the same steps to solve an inequality as you do an equation. And however, you're going to switch or flip or change the inequality symbol if you either multiply or divide by a negative number. Hopefully this is all review. If it's not, then you may need to watch this more than once. So we're going to do a couple examples. We're going to look at this. This we're going to kind of treat as an equal sign unless we divide by or multiply by a negative. And then we're going to graph it. So we've got 5v plus 1 greater than 7v minus 17. We're going to move our variables to one side and our numbers to the other because we're trying to isolate our variables. So we're going to move the variables. Let's go ahead and just move this negative 7v, negative 7v. When we add these together, we're going to get negative 2v plus 1 greater than, this cancels out, negative 17. I'm going to move my 1 over to this side, so I need to subtract 1 from both sides. I'm left with negative 2v greater than negative 18. Now, I'm dividing by a negative, in which case I need to switch the sign. It needs to go from greater than to less than. So because I'm dividing by a negative number, it's going to be v is less than positive 9. Negative over negative is positive. Okay, so that is my inequality notation. If I have a number line and say this is 0, this is 3, 6, 9. So this would be negative 3. My interval note, I'm going to graph it. V is less than, so it's going to be an open dot at 9, because 9 will not satisfy that. And then I'm going to shade all of the numbers that are less than 9, and so that's going to be shaded all of here. All of these numbers are less than 9. My interval notation, since it's an open dot, it's not included, we're going to use parentheses. So we're going to basically say the smallest number that it can go to would be negative infinity. Right? It can go on and on and on to negative infinity. But it's got to stop at 9. And we're not including the number 9. Okay? Let's do this one. 21x minus, I'm going to distribute 15x minus 27 is greater than or equal to 7. I've got like terms here, so I'm going to combine and get 6x minus 27 greater than or equal to 7. I'll add 27 to both sides. And I'm going to move it over here a little bit. 6x greater than or equal to 34. Then divide by 6. I'm left with, now this is not a negative number, so I don't need to split the sign. X is greater than or equal to, and I can reduce that from 34 divided by 6 to 17 divided by 3. How do you graph a fraction? Well, You do it the same way you'd graph a whole number. You're going to look at your number line, and you're going to kind of figure out where on this number line should this be. If this is 0, 17 over 3 is not quite 6. You can plug that into your calculator, but you're going to find it's not quite 6. 18 over 3 would give me a full 6. So if this is 3, and this is, well, yeah, let's just do it this way. 6. This right here, just not quite to 6, would be 17 over 3. It's going to be a closed dot. It's not quite to 6 yet. It's going to be a closed dot, and it's going to be all the numbers bigger. So 7, 8, 9, 10, those are all going to be bigger, so we can shade all of those numbers. All right, let's just do number 6. Oh, interval notation. I'm sorry, I forgot to do that. So the smallest this number could be is going to be 17 over 3. We are including it. This is going to be a closed dot, so this means brackets. This one meant parentheses. Because what we're learning is a new language, so we're going to use a bracket here to explain. It's basically a new language. It's a symbol that states to the reader that this number is included. Then this goes on and on and on to infinity. And you always use a parenthesis to include infinity because infinity is not a number, it's a concept. And so it cannot include the number infinity. That doesn't exist. All right. Let's do this one where there's variables on both sides. 3, I'm going to distribute that negative, minus 4m minus 1 greater than or equal to 5m minus 25. So we're going to combine our like terms. We got this and this. That's going to be 2 minus 4m greater than or equal to 5m minus 25. I'm going to do this kind of in one step. Hopefully you're going to get this. I'm going to add 4m to both sides. And I'm going to get 0 here, and I'm going to get 9m here. Then I'm going to, I got to move this 25 over to this side. I'm going to add 25. These cancel the other out. And these cancel each other out, and I'm left with 27 is greater than or equal to 9m. Then divide both sides by 9. And I'm going to get 3 is greater than or equal to m. So we've got 3 is greater than or equal to m. So if I'm on my number line, this is, say, 0. This is, we can do 1, 2, 3, negative 1. Greater than or equal to, this is going to be a closed dot. Then we're going to highlight everything that is 3 has to be bigger. 3 is bigger than any number m. So that's going to include all of that. To write it in interval notation, the smallest it can be is negative infinity. The largest it can be is 3. And since we're including it, we're going to use that bracket. Okay? I'm going to pause for a sec. Alright, so then we're going to turn the page. I'm just going to do a few more of these and then move on. So Here we've got 24x minus 27 greater than 24x plus 4. Now I'm going to subtract 24x from both sides. And I'm left with negative 27 is greater than, these cancel each other out, this cancel each other out. It's greater than 4. This is no solution. So there is no solution. Moving on. If we've got this one, 8 minus 14r minus 21 greater than or equal or less than or equal to 3r minus 30. We're going to combine our terms. We get negative 14r minus 13. I'm going to add 14r. Why am I adding 14r instead of subtracting 3r? Because I like to keep this positive in the classroom and in math, if I can. 17r. Now, I'm going to add 30 to both sides. I'm going to be left with 17 less than or equal to 17r. Divide both sides by 17. And I'm left with 1 is less than or equal to r. So to graph that, I'm going to go to my, you can number your numbers however you want. And I'm going to put a closed dot on 1, and r has to be all the numbers bigger. Now, that interval notation, you're going to have to state. We've got 1, which is included, so we put a bracket there, and the numbers go up to positive infinity. So if you noticed, my interval notation, the number that it starts with is going to basically correlate with the dot. Do you see how this is 1 is on this side and infinity is on that side? If you flip back over here, negative infinity is on this side and 9 is on that side. It's one way to do it. Your dot is on this side, your infinity is on this side. Your 3 is here, your infinity is over there. I don't know, hopefully that makes sense. We have one like this, 11x minus 4 greater than or equal to 6x minus 3 plus 5x. We're going to be left with 11x minus 4 greater than or equal to 11x minus 3. Then we've got subtract 11x, subtract 11x, and we're left with negative 4 is less than or equal to negative 3. So the question is this true? Is this true? Is negative 4 less than or equal to negative 3? Yes. So it's all real numbers. So your interval notation is negative infinity to positive infinity, and your number line is basically 100% covered. So back up here at no solution, we should have asked ourselves, is this true? Is negative 27 greater than 4? And the answer is no. So that means no solution. Okay, moving on. So we've got set notation, which is another way of expressing the solution to an inequality. So basically, if we have this as our answer, you've got set notation, which basically is the set of numbers regarding x is greater than 5. So all you've really done is you've basically taken this and have inserted it there and added these fancy brackets. And you're talking about your x's. So that actually reads as the set of x values where x is greater than 5. That's basically what this is, the picture of that in words. All right, moving on. We've got compound inequalities. Now this is just basically when you have two or more inequalities graphed together. On the same line. Okay, so we've got two types. We've got the OR type, which is basically when you have them going in different directions. So you can see this one is highlighted with a closed dot over here and over here. It's either going to be these sets of numbers or it's going to be this set of numbers. So you could basically write the word OR in there. It doesn't include those numbers in between. So you could write those as x is less than or equal to -4. And I'm saying less than or equal to because it's a closed dot. Or x is, I think that's supposed to be an open dot. This is supposed to be an open dot. X is greater than 1. Your interval notation is going to be about the same, and it's going to be basically you start over to the far left and you've got -infinity and it stops at -4, which is included, so we use the parentheses. That means OR, that symbol means OR, that U. Then we start at this 1 and we're using the parentheses. Oh, I'm sorry, this should be a bracket. Hopefully you caught that. This should be a bracket because it's a closed dot. This is a parentheses 1 to infinity. So this basically is your closed dot. This is your open dot. So hopefully you're noticing that this and this. Okay. Moving on. So when you're solving for OR inequalities, you have to solve each part of the graph on a number line and show the solutions. So here you've got two different equations that you're solving. So we're going to solve this one first. So we'll subtract 4 from both sides, and we get 3x is less than or equal to 6. X is going to be less than or equal to 2. So to graph that, it would look like this. We'd use a closed dot, and we would highlight everything where x is less than that. The interval notation would start out at -infinity and stop at 2. And since it is a closed dot, we're going to use brackets. So bracket there, always a parenthesis around the infinity sign. The next one is 5x is greater than 45. Divide each side by 5. X is greater than 9. So I'm going to take my 9 right here, and use an open dot. That should be an open dot. And then highlight. I'm going to redo that so that you can see that that's an open dot. So I've got an open dot at 9. And we're going to highlight everything that is bigger than 9. So that would look like, since it's open, we're going to use parentheses because it's open. So that is going to be this symbol, 9 to positive infinity. Okay. Moving on. We're going to solve this, subtract 6 from both sides, and these cancel each other out, -1. We're going to use a closed dot, and a closed dot means brackets. So we're going to go to n at -1. We're going to use a closed dot, and it has to be less than that, so we're going to shade over there. We're going to start to the left, -infinity. We're going to stop at -1, and we use a bracket. So this reads all the numbers from -infinity up to and including -1. For the next equation, 9n plus 7 greater than 43. Subtract 7 from both sides. 9n is greater than 43 minus 7 is 36. Divide by 9, you get 4. So now we have an open dot because it's not equal to it, it's just greater than. So we're going to use an open dot, which is parentheses, and it's all the numbers bigger than 4. So we're going to use the open dot 4 up to infinity. Okay. All right. All right, let's work problem number 6. Sorry about that. So basically what we're trying to do is we are solving these equations. We are looking to see how can we communicate what numbers are covered in both interval notation, which looks like this, as well as graphing it on a number line. So it's really no different. We're just solving the equation, graphing it on a number line, and then showing it in a special interval notation. So don't get bogged down in the steps. We're just going to solve it first. So just solve, graph, and then figure out your interval notation. Okay, so we're going to solve this. Before we do anything, let's get rid of that denominator, since that is the only thing. Since the only thing on this side is the fraction, we can first multiply by -3. When we multiply by -3, we're going to flip the sign. So we're going to get 8 minus x, then we have to flip that sign, greater than or equal to, and -3 times -5 is positive 15. Okay, so at this point, Now we need to get the 8 over to the other side, so we're going to subtract by 8, and we're left with negative x greater than or equal to 7. But we have a negative here. So in order to get rid of that negative, I'm going to multiply everything by negative 1. So I'm going to negative 1 times negative 1, multiply both sides of the equation by negative 1, and I get a positive x here, but I need to flip that sign because I'm multiplying by this negative, and I get negative 7. Okay, so then to graph it, so we've solved it. Now we're going to graph it. We're going to go up to our number line. We're going to go to negative 7. We're going to put a closed dot because there is a greater than or equal to or less than or equal to, and it's all the numbers less than that 7. So I'm going to highlight this way. This next problem, so that was this problem. Now this next problem, the fraction is not the only thing on this side of the equation, so we need to get, before we multiply everything by 2 to get rid of the fraction, we need to get everything else on the other side of the equation. So I'm going to subtract 5 from both sides. So 5 minus 3 halves x less than negative 1. I'm going to subtract 5 from both sides. And I'm left with negative 3 halves x less than negative 6. So now we're going to multiply everything by 2. And I'll be left with, so I'll multiply everything by 2. And this side as well. And I'm going to get negative 3x less than or equal to negative 12. And then when I divide by negative 3, I'm left with positive x greater than, I have to flip that sign, 4. Because negative 12 divided by negative 3 is 4. So then I come over to my number line, and I'm going to come up to 4, but I'm going to use an open circle because there's no equal to sign under there, and x is going to be all the numbers bigger than that. Okay? Hopefully that helps. Okay, last little bit. This is another type of equation, and these are our AND equations. Basically, it's when we have two equations but the numbers are going to be basically the same. They're going to overlap. They're going to overlap. That might be a good way to put it. Okay, so we've got this situation where we're looking at all the numbers that are greater than -2, right? X is going to be between -2 and 5. So we've got these values right here, which is, this is a closed dot, this is all covered, and then this is an open dot. So all the numbers in between there. So X can be any number that is greater than or equal to -2 or less than 5. Or and less than 5. So we're talking about just a small bit of numbers. So there's a few different ways you can write that. You can write it like this, and I like to write it like this because you can basically see this is the border here, this is the border here, and X has to be in the middle. So X has to be in between those two numbers. It has to be bigger than -2, smaller than 5. So you can write it like this, or you can write it X is greater than or equal to -2 and x is less than 5. So either one of those are correct. Oh, here, let me move that ladybug. Woo! Move that out of the way. All right. Well, the interval notation is going to be, again, same thing. When we're doing brackets, we include. When we do parentheses, we exclude. So we're including the -2, so we're going to use a bracket, -2, comma, but we're not going to infinity. We're stopping at 5. But we're excluding that 5, so we need to put the parentheses there. All right, so because the solutions to are an and, they fall between the two endpoints. And so we can write it either as x greater than or equal to -2 and x is less than 5. Or we can go ahead and put -2 greater than or equal to x greater than 5. This is just a little bit cleaner. Okay, so let's solve some of these. We've got 2x plus 3 greater than -9. We're going to subtract 3 from both sides. 2x greater than -11. I'm sorry, 12. Woo! Then we are going to divide by 2, and we get x is greater than -6. So there's one boundary. These are our boundaries now. Then we've got 8x minus 2 less than 30. We're going to add 2 to both sides. 8x is less than 32. X is less than 4. So here's our other boundary. So now when we're graphing this, you're going to notice, so if I said x is greater than -6, I would take my pen and say, okay, there's -6, it's got to be all the numbers greater than that. Then if I was going to graph this and I said x has to be less than 4, I would take my pen and do an open dot here and say all the numbers less than 4. But since we've got to take both of these together, do you notice that it has to stop here and stop here, so it's just in between. It's just in between. So the answer is this blue line. This is just showing you this is how you'd graph this by itself. This is how you'd graph this by itself. But the answer is only where they overlap. So you have to look at the overlap, since it has to satisfy both. Okay? So let's do, we'll just do these others, and then we'll be done. So I'm going to do them hopefully kind of fast. -2 less than or equal to a minus 1 less than or equal to 6. This is basically, you can take those two equations and put it into one. So what you basically have is two separate equations using this. So what you do is you kind of have to work it both ways. You have to say, okay, if I was going to solve this equation, I would add 1 to both sides, and then I would say, okay, that's going to be -1. A is less than or greater than or equal to -1. Then you kind of come over to this one, and it's hard for me to do that with since I write left-handed. You're going to say, okay, wait a minute. You're going to add 1 to this side, because now you're solving this equation, and you're left with A. This cancels each other out. A is greater than or equal to 7. So you're left with this. That's one way to do it. And notice, you basically are just solving two equations simultaneously. We did the same thing up here, we just didn't do it simultaneously. This time we did it simultaneously. So that's how you do that. If I were to graph this, I would start at -1, and I know it has to be a closed dot, and A has to be greater, greater. And then I'm going to say, okay, but it can't be bigger than 7. And so that's a closed dot. And it's going to go less than. And where is the overlap? The overlap is right here. Right in between those two. And that's what your graph would look like. So your interval notation would be it includes and includes. So since it includes, we're going to use brackets. So it would be -1, 7, and there you go. Okay. Now, you can take these apart. I'm going to show you how to do that. You can take these apart and just say 28 is greater than -2 minus 10m. And so that's this equation right here. Then you can also rewrite this equation and say -2 minus 10m greater than or equal to -7. And then solve both of those. All you've done is you've taken, if you don't want to do it like this, where you're solving two equations at once, you can do this and solve them one at a time. So then you would add 2 to both sides, get 30 greater than -10m, divide by -10. Make sure you flip your sign. You get 30 less than m. 3 less than m. Then here, you would do the same thing. Add 2 to both sides. Get -10m greater than or equal to -5. Then you're going to divide by -10. Flip your sign and get 1/2. So now, if you're going to graph it, you're going to go to 3 is going to be an open dot. M has to be greater than 3, so that's going to be, oh, I'm sorry, that should be negative. That's -3. Oops. Sorry, guys. Hope somebody caught that. So we've got a -3. M's got to be bigger than -3. N has to be equal to, less than or equal to, so I'm going to use a closed dot. And then the overlap is right here. This is where they overlap. This is your answer. This is your answer. The overlap. Alright, so then your interval notation is going to be that the very smallest it can be is -3. And that is m. The very biggest it can be was 1/2. So to write that interval notation, we're going to use a parenthesis, -3, and a bracket for 1/2. Alright guys, hopefully that helps. Good luck. Behave for your sub. Thanks.